Hey folks, we're on to chapter 1.7 here, looking at database systems. And now this is the actual system itself at large, not just the software component of the database management system. So while the database management system is the key, most important part of a database system, because without the database software, you're not really going to have a system, we're going to look at all of the things that go into making this system work. And it's actually probably a little bit larger than you'd imagine. Which is kind of cool to look at all these different pieces here. So before, when we looked at the file system, right, every different group had its own file system, right? You might have one system here with their data, and you might have a system over here with their data, and maybe the sales department had more information, right? They were responsible for customers and for sales and for inventory. Maybe you had accounting, maybe you had HR, right? You had all these different groups here, right? Sales, and I don't know, whoever else was over here, maintenance or something. Sure. We would have all these individual ones here. But when we move into a database system, that was a weird thing there. The goal here is to get all of the data into one big bucket. And for some reason, we like to draw these as cylinders. This is kind of, imagine this was our little cylinder here. That's like a nice little 3D view here. So this is our database. And all of our files can go into here. So we can manage all the relationships between data. We can manage all the metadata. We can have, all the different pieces here at once. Now, the database system itself needs hardware. Unless we're looking at cloud databases, but generally, maybe not even generally, but we used to have to run all these on your own hardware. It was a little bit trickier to manage cloud databases. But somewhere there is hardware for that database management system. Whether or not you need to manage the hardware or not, there is hardware for it that it runs on somewhere, right? That is the server that it's running on, that's the network that it's on, that's all the other devices that are a part of it, however we need to connect to it, all the cabling, all that good stuff that goes into hardware. And then we have the software, right? You have the operating system that the database management system runs on. Right? If it's Microsoft SQL Server, it's probably running on Windows. If it's Oracle, you can run on a couple different operating systems. If it is IBM DB2, it might run on that particular operating system for it. It really just depends on what you're doing. Right? And not all database management systems, all the different software can run on all the different operating systems. So typically we would have them in pairs, although Microsoft's working hard to make Microsoft SQL Server work on some other operating systems. That's kind of interesting. Well, we have the operating system software, and then the nope, that's backwards. DBMS, the database management system, the actual software itself. We have some open source options as well. The book seems to only mention some of these big ones, but PostgreSQL or Postgres is a really big open source system. MySQL is another big open source one. You don't just have to use the expensive Microsoft or Oracle versions for database management systems. So as we look into moving towards this database system, we have all sorts of different people that are going to be interacting with it, right? We have our people. And other things in software are the applications that communicate with the database, right? What talks to the database to do all of our applications? That's another important piece there as well. So how are our users getting at it? When it comes to people, right, we have our system administrators, system admins. We're going to manage the system that our database runs on. We're going to have a database administrator, commonly referred to as DBA, or database administrator. They're the ones who make sure that the database management system is running the way that it should. And we'll get to more of that in chapter 16. The book likes to imagine there's a role called a database designer. I guess if you're in a large enough organization, maybe someone is dedicated just to designing databases. I'm not really sure if that's as practical anymore. But they ensure that the database is designed properly. They work with the business to make sure that we're getting the right business rules, we're having the right form, we're able to capture all the right data that we need to generate good information, to get good business intelligence so that we can run our operations effectively. You might also have regular systems analysts or programmers. I'm quite fond of programmers myself, who work on these applications that then talk to the database. So they're more of the technical side of people who are going to be working with the database here. Maybe they're designing the data entry screens, or they're designing some of the reports or some of the procedures, ways that we go about getting at the data, manipulating the data, giving reports out. And then we have everyone we call the end user, people who actually use the programs then that our analysts and programmers set up that interact with the database that was designed by the designer, that's managed by the DBA, on a system managed by the system administrators. So it takes this whole group of people essentially to make this all work. And depending on your organization, like this might be one person. This might be a team of people. The larger an organization you get, the more specialized you typically be, or more specialized roles you might have. So if you're large enough to need specialized roles, you might have just a system administrator or just a database administrator. But at smaller organizations, sometimes one person does all of these roles. So that's looking at people in the database system. There's now other pieces of the database system are the procedures or our business rules. So procedures or business rules, right? How does data get in? How do we interact with the data? What are the policies on how we're going to manage that data? How do we audit the data? What kind of things we're going to do with it? And this is one of the questions that comes up in the discussion, is who ultimately has the rights to the data? There's been a big movement over in Europe, thankfully, for data protection and privacy and data ownership. And it's this thing called GDPR. I don't actually remember what it stands for because I never have to look it up. We could go Google it, I guess. But GDPR gives ultimately the right to the person's data who owns the data, right? And if another company is storing your data, you should have the right to tell them to get rid of it. So the right to delete your data from their system, which is huge. Most of our systems weren't actually meant to delete data, and that became a very interesting thing to be able to do. But thanks to that, Google and some of our big tech companies now have view all of my data and see all the things we know about you, or delete yourself from our system laws in place, which is really cool, or tools in place to be able to do the things that law required them to do in Europe. So procedures are part, and of course data is part of the database management, or the database system itself, the actual raw data that we put in that we're going to turn into information and derive some business intelligence from it. So some of the functions of the DBMS then, our DBMS, our database management system. Some of the things it needs to do is it needs to manage the data dictionary. Now the data dictionary is our metadata, right? This is the data about the data. This says, okay, well, what is this field here? What is it? What format is it? How are we going to relate all of these tables? Right? This idea that our data is self-describing. We're going to say, okay, this is the list of columns that I have in my table. This is a list of types for each column. These are the relationships that I have. And what's really cool is this information is actually stored in a database table itself, which is kind of crazy. So the rest of the database is defined by data in a system-defined database, which is pretty fun. And that makes up our data dictionary. So it's all the metadata about the data, right? The data characteristics and relationships. Our database management system is also responsible for data storage, right? No longer are we stuck to a single file per whatever grouping of data that we want to have. We don't need a file for sales. We don't need a file for this, a physical file on disk. The database management system is responsible for managing data storage. So it's going to put files wherever we want. There's a whole chapter on performance tuning and tools and techniques that we can do for that. But one of the things the database is really good at is creating physical files and reading and writing those physical files, storing this data here. So those, again, are the physical files, and most of the time for us it's able to just bundle itself together into a single file. So in terms of what we see, it just looks like one big file, but behind the scenes it manages all that, which is really cool. The DBMS is also responsible for transformation, so transformation of data and presentation of data. Presentation. Right, so when we are entering data into the system and we need to transform it, right? If someone enters a date in a given way, we're going to transform it to be our standard date format, right? Or if they are entering a certain block of text here, we're going to transform it to fit a certain way to do some particular parsing on it here, or how do we want to present it? Right? Maybe we always want to present it in someone's local format or local time. So the database management system is responsible for transformation and presentation, and it's responsible for security. Right? Who has access to what in the database? So security management is part of the database management system's job. And again, this is why Excel is not a database. Right? There's no real security that happens in Excel, and it's not a multi-user system anyway. We have security, and we also have the multi-user controls to make sure that when multiple people are using the system all at once, we can access it concurrently and without compromising its integrity of the data. Later on in chapter 10 or so, when we talk about transaction management and concurrency control, we're going to look at how the database management system does some of these things. Right? How does it go about making sure that if, hey, I want to update customer B's record and you want to update customer C's record, well, sure, that should be perfectly fine. But what if we both want to update customer B's record at the same time? What's going to happen there? So there's some controls around that. Another really important job of a database management system is backup and recovery. So doing the backup of your database, where can we store a backup copy of my database, and then how do I recover it if I need it? Backup and recovery. I know there's a really good story, if you're familiar with Schrodinger's cat. This was this crazy guy had this idea that if you put a cat in a box and you leave it there for a while, until you open the box, you don't really know if the cats are alive or dead. I think that's the gist of the story. But backups are essentially Schrodinger backups unless you test your recovery process. Right? If you can't successfully recover from your backup, the backup's worthless. It's essentially dead. Right? You have no idea if you actually successfully backed up. So that's part of the database management system. Not just backup, but also recovery as well. I had a really bad problem. One of the customers I worked with one time, and we wanted to restore a database from a backup, and it turns out the backup hadn't been running for 3 months. So that was really, really unfortunate, and that was a bad situation. A database management system is also responsible for data integrity. And now there's all sorts of cool tools in the database to make sure that we are enforcing integrity, minimizing data redundancy, and maximizing our data consistency, which is just a really cool way of making sure that I'm not going to have to enter the same thing twice. And every time I do want to enter something, I can reference that master list. Like when we looked at that list of certifications, right? We can have one single master list of certifications, and we want to say, hey, this employee is certified. We can reference that. So it always looks in the same place. Right? The database management system is responsible for data access. The language used, right? Or the application programming interface, the API. So how do we get data in and out? Now, typically this is SQL, the structured query language. That's SQL, structured query language. Some people say SQL, some people say SQL. I think I go back and forth. Usually I say SQL, but sometimes it's SQL. It just depends on what my brain wants to do at the moment. But how do we interact with it? So SQL is a standard. It's actually an ISO standard, an international standard for working with databases. So just about every database management system will support it. But again, there's other particular ways. If you want to use this API, you can do things directly in code with languages, right? Depending on what your language that you prefer, Java or C# or C++ or PHP, any sort of language essentially will be able to work with the database, because that's what all things do nowadays. Just about every application out there is backed by a database. And then database communication interfaces, so ways that the database can communicate. So DB communications, right? Whether or not that's automatic reports or some way that other systems can get in and other productivity applications can access it. So not necessarily just like a raw API, but some built-in database communications. You can look more at that later on in some other chapters as well. More 15 that we kind of skip, like how do we program and connect to it with web technologies, and we don't really quite get there, but that's okay. So those are all the pieces of a database management system. Again, this is why Excel is not a database management system. Excel's great. I don't mean to bash on Excel, but it's not really, it's used for too many things that it shouldn't be. Hey, Ian, you want to come say hi? My kitty wants to say hi. I think he's lonely right now. Ian, say hi. Hi, everybody. All right, maybe he'll stay in my lap while we finish this up. So as we move towards working with database management systems, you can see that there's a lot to it. It's complex, and anytime you have to deal with complexity, it tends to mean dollars. Right? If you need to get specific people to do it, it's probably going to increase your cost to manage your databases. It can be a little bit tricky. So there's cost involved. There's managing it is a little bit tricky because everyone has to buy into using the database. If everyone has a database except for the one person who still keeps their paper files, it's not going to work very well. Dealing with currency and staying up to date. Any database management system is going to have patches, so you need the IT folks who can manage that to take the system down, apply the patches, bring it back up. Dealing with particular vendor, right? Once you pick a database management system, it's rather difficult to change to a different one. So if you pick Oracle, you're generally stuck with Oracle for quite a while. It's a large effort to change database management systems. And then just managing upgrades and replacements. So all sorts of IT issues here. Things get old and need to be replaced. Hardware needs to be replaced. Software needs to be replaced. Licenses need to be renewed. All that sort of thing. And keeping everything up to date. So there's definitely a lot to go into it. And some of that comes down to business decisions. Is, well, if this particular part of my business, if it's going to cost tens of thousands of dollars to implement a database and have someone manage it and get all my people trained to use it, is it really going to be worth it for me if we're not getting a lot of savings out of it? Maybe it's fine to just keep a paper log, right? I don't think you see very many stores that usually they have their bathroom cleaning log, right, when you go into the bathroom. I've never seen one of those electronic. It's always a piece of paper here, because how much is it going to cost to manage tracking when the bathroom is cleaned in a database, and what are they going to gain out of that versus just having a piece of paper on the door? When you walk in, you put your initials on it, and the time you said, okay, I cleaned the bathroom. So some things aren't necessarily worth putting in the database management system, and that's all a business decision. All right, and we got one last section here in chapter 1, and then we'll call it a day.